Hello everyone, welcome to Bioinformatics 101. I'm your host Pat, and today we will be talking about downloading SRA data and getting started with bioinformatics. So if you're just starting out, it's good to get some publicly available data just to play around with. So I'm going to go over the steps to get that data on your computer. So the first thing that we're going to do is we're going to go to the SRA website. So if you just type in SRA NCBI, there are other databases out there. This is the one that's most widely used for the United States, but a lot of countries have their own similar database. And here in the search bar, I'm going to search for a NA12878 sample. So this is a sample that NA12878 is an individual that is one of the most characterized, meaning that they've been sequenced the most and their genome is almost used as a truth set for a lot of testing and evaluation. So you can download whatever data you want to download, but this is what I'm just using for an example. So when you type in this, you see that we have a lot of results that I want to pare down somehow. So here on the sidebar, we can see that there's a lot of options that they give us. I'm going to go for public data. I'm interested in DNA data. Exome or genome, a lot of this will depend on what you are trying to work out or work on. I'm going to choose exome because exome is a lot smaller, and depending on your storage capabilities, this will be a better option if you're just starting out. I'm looking for paired end reads, so you can have single end reads or paired end reads. Most places use paired end reads now. It's more accurate, and if you can find paired end reads, that's what I would go with. I'm gonna go with Illumina, because that's the platform that I'm most familiar with. And I want to look for something that has FASTQ files. So really these two file formats, I have a previous video that goes over the BAM format, but these are what you can think of as your starting point. So FASTQ files are kind of the raw sequence data that comes off of the sequencer that you would do all the analysis with. BAM is just a file type that has already been aligned to a reference genome. So each of these will be fine for a starting point because you actually can pretty easily convert between these two file types. But for the time being, I'm going to use FASTQ. Okay. And here we have a couple options up top here. There's one that was sequenced on the NovaSeq, which is Illumina's most recent platform, and then right behind it is the HiSeq 4000. You can kind of see the relative sizes that they have here. So this one is going to be a little bit bigger. You can see the download sizes. I'm going to go with this. This is going to have a little bit more coverage over the genome than this one would based on the download size. Let me go ahead and click on that. And this gives you some information about the experiment that was run. What I'm interested is in the data, which is this section down here. So I'm going to go ahead and click on this. Okay. And this will bring up a lot of the information about the sequencing that was done. So you can see it was done on Illumina, it was whole exome sequencing, paired end reads, all the stuff that we selected previously. The main thing that we need is actually this number here. So SRA has their own toolkit that you can download that helps you pull their data very easily. So I'm going to bring up a terminal here. I covered in one of my previous videos downloading Conda to your computer. If you haven't done that, you will need to do that previously, so look back at that video. So let me go to Conda install SRA Tools. So this is the tool we're going to want to install. There's a couple options they give you. Let me show you this. So this first option from Bioconda, if you put this in, you'll actually see that it's an outdated version. So it's version 2.8, which doesn't have a tool that we would like to use that was added in 2.9. So I've already installed this on my computer, but actually this second link is 2.9. So I would recommend using the second link to do your installation. And you'll see here, I've already installed this installation. So once you have that installed, the main tool you'll be using for pulling down data is the prefetch. So if you just type in prefetch, this should pop up in your terminal. Let me make this a little bigger. So it's super simple to use this. All you have to do is do prefetch, and then we're gonna grab that number from the SRR number right here. Copy that. Go back to, sorry, my mouse is acting weird. Go back to that, and then you would just execute this command right here, and that would download the data. So one thing to be sure about is your storage capabilities. So one thing that SRA Tools does is it will download the data to a default location on your computer, and that location is your home path. So let's go here, home, I think it makes NCBI, public, SRA. So it'll make these 3 folders for you and place your SRA data in this folder. So if we go here, we'll see I've already downloaded this. And these are not insignificant files. So this data was about 16 gigabytes. So make sure before you start this install that you have 16 gigabytes available to you. And you'll actually need even more, because this in itself is a super compressed file format. So it contains a ton of information about the sequencing and other things as well, but we're really just interested in the FASTQ files. So there's a separate tool that SRA Tools comes with. Let me clear here. And that would be, so they had, like I was talking about, they had FASTQ dump, and this is a tool that was in that 2.8 version and in the newer versions, but in the 2.9 version, they actually came out with faster Q dump, which, as you can tell from the name, is faster. So that's why I chose to install that one as well. So this is the command you'll need to extract the FASTQ files from that SRA file. There are a few options that you will want to do. So since we are looking at paired end data, we want to use this split files option. Let me see I'm just going to look up the, so this right here, this was the command I ended up using. So faster Q, I pointed to that SRA file, I did split files, and then I was able to set my output directory. So I have a separate hard drive in my /projects folder that's mapped to this folder. That's what I use for storage. So if I go to this, you can see that I have extracted those files out. One thing to note is you can see here that these files are compressed. So I use the tool gzip to compress the FASTQ files. SRA, when you do this conversion, it will output them in an uncompressed format. So these are actually much larger. When I did this originally, this came out to about 50 gigabytes a piece. And remember, this is whole exome data. So if you're doing this with whole genome data, this is going to be hundreds, if not terabytes of data. And you need to make sure that you have the storage capability to handle that. So this was the command I ran, and I output it to this directory. And this is going to take a while. So it's one of those things you start and then you walk away from your computer and let it run. You can mess with the threads if you want to speed it up or slow it down depending on your computer capabilities. But you should expect this to take over an hour. So, but once you have that, you can compress the files, get them into a more manageable file size, and then you will be good to go. So here I have my FASTQ data, and this is something that I can start working on alignment. After alignment, I can take this through variant calling. I can really learn the whole bioinformatics pipeline from this starting data. So I hope you guys enjoyed this video. Please let me know if you want to see any other topics or any ideas for future videos I can do. I'm hoping to post more regularly. I haven't posted in a long time. So thanks for tuning in. I appreciate it, and have a great day.